So I'm making an effort to try to get away from this discussion involving deities and creators of the universe and such, and try to get more into more interesting topics like science. Um, I'm kind of one of these people that questions everything. So I'm curious and I want to know, I want to understand how things work. Now there's some uh, concepts that hopefully there's some smart people out there that can help me fill in some blanks here, but I have some curiosities, some questions about Einstein's relativity. Now there's I don't know if it's a famous experiment, but there's an experiment or a thought experiment at least where you have, and I don't remember what they call it, but it's kind of think of this. I don't know if it's a fictional device, if you could create something, but imagine there's a photon that's bouncing back and forth in between this thing. And as this moves forward, you can measure the distance of a photon bouncing back and forth in here and time that, record how long it takes to go from there and back, and measure the speed at which that photon must be traveling. Now, if the thing that is carrying this is moving through space while this is bouncing, if you could draw a line from where that photon travels, it's a longer line along the path as it's traveling. So it hasn't traveled just this distance, it's traveled this distance. So all the way from here to here or whatever. Now, the idea is that whoever is riding along with this vehicle that's carrying this thing would always measure the same time that it takes to go from here to here. But in reality, the photon actually does travel this longer distance. So how could the occupant of this vehicle measure the same time, the same speed of this photon from here to here, here and back, as standing still as it would be if it's moving forward through space, even if it's moving close to the speed of light? Well, that's due to time dilation. Time, as at least they convey it in physics as the common understanding is, and I'm not going to go into this whole big thing about time. I have my own understanding and ideas and theories about time. But due to time dilation, this photon still appears to be traveling the speed of light according to the occupant on board. But in reality, that photon really is traveling that further distance. And if somebody watching this thing go by and measured that time and that distance that it took that photon to go from here to here, they would also measure the same speed. It's a longer distance and a longer time subsequently, but they would measure the same speed. That's because the time reference of the observer is different from the time reference on the occupant in the moving vehicle. But now, the occupant in the moving vehicle, I think, would not see a photon bouncing in here if they're moving close to the speed of light. Because if you're moving close to the speed of light, and this was a question I had in a previous video that so far nobody has responded to, is a photon emitted instantaneously in the direction it's aiming, or does it carry the forward momentum of whatever it is that fired it in that direction? My thinking is, my understanding is that it's an instantaneous event. If we shot a photon straight up and this vehicle is moving forward close to the speed of light, well, guess what? That photon's going to miss the mirror. It's never going to bounce back. The occupant of that vehicle would have to aim the photon cannon ahead in order for that photon to make it to that mirror, and then it would bounce off that mirror. Okay. This is hard to do. So it goes up, so it's aiming ahead. So as it moves forward, it's going to hit there, but then it's going to bounce off, and I suppose, I don't know. I'd have to work out the timing. But the thing is, you would have to aim that photon to lead your target. Because another thing that has been said about all this is that if you were in a rocket ship flying near a rocket ship that was flying the same speed, maybe not a rocket ship, a spacecraft, they were both traveling, say, 98% of the speed of light. An occupant in this one looking over at this spaceship would not see the spaceship right directly across from them. They would see it. It would appear to be behind them. Well, why is that? Because photons are emitted without any forward momentum. So the moment this photon left this ship to 90-degree angle toward this ship, by the time that photon got to this ship would have moved ahead. The occupant sitting up here would have never seen that photon. So they can't look over and see any photons that are coming straight over, because the photons that are coming straight over are hitting the back of the ship or missing it completely. It's only those photons that are leaving the ship going in a direction that's leading the ship, so that by the time this ship gets up here, the photon that left this ship back here reaches the occupant up here that's looking over to see this ship but can't see it because they're seeing photons that were shot out in front of the ship. So it looks like the ship is behind them. That's why when you're looking at this ship from this ship, they see the same effect, that this ship looks like it's behind. Each one thinks the other one is trailing when they look over, because their photons are coming at an angle to catch up to where they are. So how can those conditions both be true? Something seems like somebody's not quite thinking through this. Actually, I kind of lost my own point here. I mean, that seems like that's the logical thing, that, in this experiment where this photon's going this way, wouldn't they have to aim that photon cannon ahead to lead, so that when that mirror, when it comes up to this height, it hits the mirror, and then by the time as it bounces off, it'll come back down. The occupant may measure the same time, but they would also have to know what angle to angle this photon gun in order to get their photon reflected back to them. Right? Am I off base here? I mean, you can't have one without the other. If it's true that you look from one spaceship out to the next one and they're going close to the speed of light, that one looks like it's behind you, that verifies my theory that the photons are emitted without any forward momentum. They're emitted, they travel exactly in the direction that they left the vehicle. So if a photon leaves this vehicle at a 90-degree angle, it's going to go at a 90-degree angle. It's not going to carry any forward momentum as it goes out. That has to be the case if it's true that it looks like it lags behind. And if that's the case, then you would have to aim your photon cannon to lead your mirror if you're moving through space. So is that true? That's kind of a long-winded, hard to describe question. Hopefully somebody can verify this or validate my thinking on this. So anyway, I'll leave it that there. It's 9 minutes and 40 seconds. I am sure I've bored you to death. So okay then. All right, you can turn it off now.